This is lesson 3.2 on angles and parallel lines. So in the last lesson we talked about two lines cut by a transversal and the different types of angles that were formed. In lesson 3.2 we're going to build on that. So we'll still be using the same vocabulary, but because we're going to be dealing with now parallel lines that are cut by the transversal, you will have some relationships between the measures of the angles in addition to just how they're related in terms of corresponding or alternate interior or whatever. Okay, so let's suppose that you are given that the measure of angle line M is parallel to line T, and the measure of angle 1 is 60 degrees. So if I told you that this angle measure is 60 degrees, what other angles could we find? Well, we know that vertical angles are congruent, so that would mean that angle 3 would have to be 60. And we know that linear pairs are supplementary, so that would force angle 2 to be 120, whether you're using that line or that line. And then also, again, vertical angles are congruent, and the linear pairs are supplementary, so either reason there would make angle 4 120 degrees. Now, none of that relies on the lines being parallel. However, if we jump down to angles 5, 6, 7, and 8, we have to kind of use something that is going to be our basic assumption. Remember that a postulate is a statement that's assumed to be true. We're going to assume that it makes sense that when you have parallel lines that are cut by a transversal, then the corresponding angles would be the same. That is believable that those two angles are the same measure, right? So if angle 1 is 60 degrees, that would force angle 5 to be 60 if the lines were parallel. Now, a little side note here. Remember that this notation is how you say line M is parallel to line T in terms of, rather than using the word. But on the picture, if you want to show that two lines are parallel, you put little arrows like that. Sometimes you'll see them filled in like that. Sometimes you'll just see them arrows like that. I usually fill them in because I think it looks better, more clear, rather than just an arrow, which might be mistaken for just the arrow on the end of the line. So that indicates that the lines are parallel in the diagram. So again, it's kind of the difference between perpendicular as a symbol and then in the diagram putting the little mark to indicate perpendicular. Okay, so back to the diagram here. So if we have angle 5 is 60, that's going to force the vertical angle here to be 60. And notice that the 3 and 7 are corresponding and they're going to be congruent. And then we can use our linear pairs to work around, or we can use that 2 and 6 are corresponding and 4 and 8 are corresponding, so the corresponding angles will have to be congruent. So the measure of angle 2, 4, 6, and 8 are all 120 degrees in that diagram. And the other four measures were all 60 degrees. Now, it's a coincidence that the 60 and 120 is a 1 to 2 ratio. Obviously, the angle measure doesn't have to be half of the smaller angle doesn't have to be half of the larger angle. Okay, now what we just used was called the corresponding angles postulate. But as I told you in the postulate lesson back in chapter 2, there will be a numbering system for indicating postulates and theorems. I will never refer to a theorem by number. So again, the reason that they give it numbers is just for organizational purposes. This means in chapter 3 this is the first postulate, in chapter 3 this is the first theorem and the second theorem, and in chapter 3 the third theorem, and in chapter 3 the fourth theorem. Okay, so that's just for organizing, so you can refer back from a list of postulates where the different theorems came, or from a list of theorems where the different theorems and postulates came from. For this lesson in lesson 3.5, I also am not going to want you to use the names of the theorems and postulates. Sometimes I'll let you use names, but for most of these parallel line ones, I'm not going to let you. And once we get into lesson 3.5, you'll understand a little bit better why I'm not wanting you to use the names. But here's what the different postulates and theorems say. So if two parallel lines are cut by a transversal, then the corresponding angles will be congruent. Now here's a shortcut that you can use, which is if parallel lines, that's the parallel symbol, I'm going to put a transversal through it. If parallel lines are cut by a transversal, then corresponding angles are congruent. So that is the statement that I want you to write when it asks you to justify something that you know about corresponding angles being congruent. You're not going to call it the corresponding angles postulate. You're going to say if parallel lines cut by a transversal. Now, this symbol means parallel lines cut by a transversal. Okay, so that is just a shortcut way that I use to indicate parallel lines cut by a transversal. If you wanted to write out the phrase, if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent, that's fine. But obviously I'm just trying to shorten it a little bit for you. But you have to understand what this symbol right here means. So this symbol means parallel lines cut by a transversal. So again, the way that this lesson is different than lesson 3.1 is that now we have parallel lines which will force the pairs of corresponding angles to be congruent, and some other relationships we're going to go through now. Okay, so alternate interior angles. Let's find a pair of alternate interior in the picture. So alternate interior, angle 4, and what are alternate interior? Well, remember, alternate means outside the transversal, interior means between the two lines, in this case, the two parallel lines. So in between the two parallel lines, on alternate sides of the transversal, and in this picture, your transversal would be this line right here. Okay, so angle 4 and angle 6 would be alternate interior. How are they related? Well, 120 and 120, they're congruent. What about another pair of alternate interior? 3 and 5, 60 and 60, they're both congruent. Okay, for alternate interior angles. The alternate interior angles theorem says if two parallel lines cut by transversal, then each pair of alternate interior angles is congruent. Okay, so corresponding angles will be congruent, alternate interior angles will be congruent. Shortcut way to write it, if parallel lines are cut by transversal, then alternate interior angles are congruent. Again, I am not going to allow you to write the name alternate interior angles theorem because I want you to remember that you're using the fact that the lines are parallel. You're given parallel lines and you're using that to get an angle relationship in the diagram. Okay, consecutive interiors. Alright, consecutive interiors. Angle 3 and what angle are consecutive interior? Well, consecutive again means on the same side of the transversal, and interior means between the two lines. So angle 3 and angle 6 would be consecutive interior. How are their measures related? Well, let's say you had parallel lines like this and a transversal that made this 80 degrees. What would this angle measure here be? It'd be 100. If that's 80, this one's 80. How are those consecutive interior angles related? Well, 180 and 60 and 120 are both supplementary. They're not, again, it's not going to be a 1/2 kind of relationship. It's just a coincidence that 60 is half of 120. The important thing is that they are supplementary to each other. Now I'm putting this one in red because it's different than the other ones. Okay, consecutive interiors are supplementary when you have parallel lines that are cut by a transversal. So if parallel lines cut by a transversal, then consecutive interior angles, and again they're not congruent this time. They are supplementary. And I'm putting that in red because it's different than the first two. Now, your book kind of ignores consecutive exteriors, but this would also be true for consecutive exteriors. So it could be consecutive interior or consecutive exterior. So either of the consecutive exterior or interior angles are supplementary. So it would be the same thing, except consecutive exterior. Okay, alternate exterior. Let's look at this picture again. Alternate exterior. Well, a pair of alternate exterior would be like angle 2 and angle 8, because they're on opposite sides of the transversal, making the alternate part, and then they're both exterior angles because they're both outside of those two parallel lines. So how are they related? 120 and 120. That would be true for all alternate exterior angles when the lines are parallel. They are also congruent. Okay, so if parallel lines are cut by a transversal, then alternate exterior angles are congruent. Getting back to using blue because it's got the same relationship as alternate interiors do. And again, you want to notice that the ones that are different are the consecutive ones. The consecutive ones, interior or consecutive exterior, are supplementary. All the other special pairs like that are congruent. Now remember that you've still got vertical angles, just like you always did, and you still know that vertical angles are congruent. Okay, so this does not require parallel lines, but you still have vertical angles are congruent. And then what about linear pairs? Well, a linear pair would be like this one, 7 and 8, and of course linear pairs are supplementary. So you still know that linear pairs are supplementary. That does not rely on the lines being parallel. I should say are. Linear pairs are supplementary. Okay, so again, you still have that those things are still true even though you have parallel lines now. Okay, and then one additional theorem. This one I will allow you to call by name. This is called the perpendicular transversal theorem. And it says, in a plane, and it's important that you pay attention to in a plane because it's actually not true if it's not in a plane. So this is saying in 2 dimensions. Okay, it doesn't work in 3D, but in 2 dimensions. I don't like that. Okay. If a line is perpendicular to one of 2 parallel lines, so you need to be given in the diagram that these lines are parallel to each other. So T and L are parallel. And then your line is perpendicular to one of 2 parallel lines. So let's say this is your line, this is your transversal here. Okay, and it needs to be perpendicular to one of them. So let's say we know that that's perpendicular. That's our hypothesis. And so it would be like if T is parallel to L and N is perpendicular to T, then what would your conclusion be? Well, we would still have T parallel to L, that's still true, and we still have our transversal here, and it's still perpendicular to line T, But your conclusion would be, well, if, what makes sense here? If you have parallel lines and that's a 90-degree angle, what should be happening down here? Well, you know that if the lines are parallel, the corresponding angle should be congruent, so that one should also be 90. So what's your conclusion? Your conclusion is that it'll be perpendicular to the other one also. So in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other one also. So if T is parallel to L and M is perpendicular to T, I should say in a plane, then forgot to label M here. Okay, then M is perpendicular to L. Awesome. Okay, this is called the perpendicular transversal theorem. I'm going to move this down a little bit. It's kind of clogged up in the picture here. About right there. Okay, now the 3D situation is something that's kind of hard to explain without demonstrating, but basically you can have, if you have two lines that you know are parallel, and then you allow, like pretend like this line is coming towards you in such a way, let me make it a little better, coming towards you in such a way that it's not in the same plane, so it would be making a perpendicular here, then this red line would be skew to this other parallel. It wouldn't be parallel to it. It's sort of hard to demonstrate that without having, be able to show you in 3 dimensions. But again, this theorem is not true if you're not restricted to a plane. Okay, just a little review here. Name the relationship between the pairs of angles. So this is not relying on any kind of parallel lines. This is just saying what are 1 and 5? They're corresponding. What are 3 and 6? They're alternate interior. What are 4 and 6? They're consecutive interior. 2 and 7, alternate exterior. 8 and 5, vertical. And then 8 and 4 are also corresponding. Again, that does not rely on the lines being parallel. You're not even told in that picture that the lines are parallel. Okay, now in the next picture you are told that the lines are parallel. So you can see right here it says that the lines are parallel to each other. And so here's your transversal. That's a little bit thick. There's your transversal. And so why would 3 and 7 be congruent? Well, 3 and 7 are what kind of angles? They're corresponding. Why are they congruent? They're congruent because if two parallel lines are cut by a transversal, then what are we using here? We're using the corresponding angles are congruent. All right, what about 3 and 6? Well, how are they related? They're congruent because the lines are parallel and they're alternate interior angles. So if parallel lines are cut by a transversal, then alternate interior angles are congruent. All right, 2 and 7. What kind of angles are angle 2 and angle 7? Well, they'll be congruent because you have parallel lines cut by transversal, and the alternate exterior angles are congruent. So if parallel lines are cut by transversal, then alternate exterior angles are congruent. When you make that little symbol, you should be saying to yourself, if parallel lines are cut by transversal, because that's going to force you to think about the fact that you're needing parallel lines in order to make those angles have the relationship that is stated there. Okay, and then 4 and 6, why would they be supplementary? Well, 4 and 6 are consecutive interior, and remember that the consecutive pairs are the ones that are supplementary. So, because those are consecutive interior, they'll be supplementary when the lines are parallel. So, if parallel lines are cut by transversal, then consecutive interior angles are supplementary. Make sure you just don't get in the habit of always writing congruent, because obviously it's different for consecutive interiors. Okay, the next problems say find the values of x and y, show algebra, and state the postulates or theorems that justify your equations. Okay, so we've got 98 degrees in x. Well, how are those two, how are these two angles related to each other? They're a linear pair. How are linear pairs related? Well, linear pairs are supplementary. So we know that 98 plus x has to equal 180 degrees. So if we subtract 98, that would leave us 82 for the value of x. And what are we using there? We're using that if parallel lines are cut by, no, we're not. We're using linear pairs are supplementary. Okay, that's part of your answer, so I'm going to highlight that too. Alright, so we know that this is 82. When I find angle measures, I'm going to put it on the diagram so I know I have that to use. Okay, now let me go back for a second here. You're told those lines are parallel. You want to make sure you verify that every time you start one of these problems. And then how is 82 degrees related to y? Well, they're going to be congruent because why? Y will be 82 because what kind of angles are those? If parallel lines are cut by transversal, then alternate exterior angles are congruent. If parallel lines are cut by transversal, then alternate exterior angles are congruent. And we've got our x and y values. Okay, how about this one? Again, we have parallel lines, 80 and 5x minus 15. This one and that one are what kind of angles? Well, they're going to be congruent, which means they will be equal to each other. 5x minus 15 equals 80, because if parallel lines are cut by transversal, then what kind of angles are those? Alternate interior. Alternate interior angles are congruent. To solve this, we'd have 5x equals 95, and I think that's 17. No, it's not. 19? Yeah, that works. Okay, so x is 19. If parallel lines are cut by transversal, then alternate interior angles are congruent. That one didn't have a y in it, so we're finished. Okay, this one also doesn't have y. We do have parallel lines, which again are necessary in order to say that these angles are congruent. Why are they congruent? Well, we will know that their measures, 3 times the quantity x plus 9, will equal 129 because If parallel lines are cut by transversal, then what are those? Corresponding angles are congruent. So 3x plus 27 equals 129, which makes 3x equal to 102. And that'll be, no, wait, did I do something wrong? $34. 12, yeah, okay, 8 goes in evenly. I was pretty sure that one was not going to be a mixed number or decimal. It goes in evenly, 34. Okay, and then your last one, how are these two angles going to be related to each other? Well, they are consecutive interior. Even though you're not generally supposed to pay attention to the way things look, with the parallel lines, hopefully you notice that you've got parallel lines there. These angles definitely do not look congruent, right? One looks acute, one looks obtuse. And with the parallel lines, you kind of can pay more attention to the way it looks than you would generally. So how are the consecutive interiors related? If parallel lines are cut by a transversal, then consecutive interior angles are supplementary. And again, make sure you don't just start always writing congruent just because you're not thinking. We need 4x minus 9 and 75 to add up to 180. They're not congruent, they're supplementary. So 4x plus 66 equals 180. Subtract that over 114. And I think that goes in 28.5. Let's see, 32, 11, 112 plus 2 is 114. Yep. Okay, that goes in 28.5 times. With the justification, if parallel lines cut by transversal, then consecutive interior angles are supplementary. Alright, this is what's called a flow proof. You've never seen a flow proof before, but that's okay. It's just another way of organizing rather than a two-column proof. You'll see it looks kind of like a flow chart. You've got your statements in little boxes here. These are all statements. And then your reasons will go underneath it. So you're justifying kind of as you go. And it won't be 1, 2, 3, 4, 5, etc. It's going to kind of flow. So this is how it would work. Given that L is parallel to M, that's your given, that tells you that angle 1 is congruent to angle 3. So if these are parallel, why would angle 1 and angle 3 be congruent? Because if parallel lines are cut by transversal, there's not much room here, then corresponding angles are congruent. Now, why would 3 and 2 be congruent? Well, 3 and 2 are congruent because they're vertical angles. That does not have anything to do with L and M being parallel. In fact, you don't even have to have angle L in order to get 2 and 3 vertical. So, because this is not coming from the given, it's coming from the diagram. That's why over here you don't have an arrow coming from the given to that statement. It's just sort of coming from its own place, which in this case is the diagram. It's not coming from that previous given. Okay, but see these two arrows here? These two little arrows here mean, I'm going to highlight these arrows because they're kind of hard to see. These two arrows mean that those are the two steps that are being used to get our final statement, which is angle 1 is congruent to angle 2. Okay, so if angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, why is angle 1 congruent to angle 2? That's a property. That is transitive property of congruence. Now, sometimes people look at the picture and they go, oh, I know why angle 1 and 2 are congruent. I know angle 1 and 2 are congruent because they're alternate exterior angles and the lines are parallel. Why can't you use that as a reason down here? Well, because that's what you're proving. It says prove this theorem. You're not allowed to use what you're proving. You're trying to give other reasons that justify why that statement is true. Okay, so that's a flow proof. We don't do them that often. You may never see another one again. They're not very common, but it's kind of nice that you sort of see when there's a statement that comes not from the given, it's sort of coming from somewhere else, and it kind of shows how they all fit together. So this is the end of lesson 3.1.